A stack is much like a queue, but backwards. Well, it's not entirely backwards, but it has the opposite semantics. A stack is last in, first out, or LIFO, where a queue is first in, first out, or FIFO. So as you push things onto a stack and pop them off, they come out in reverse order. Let's take a look at this. We'll make a working copy of stack.cpp and we'll paste this into our working project. And I'm just going to minimize this on the left so that we can see the whole width of this as we use it. And I'm going to compile and run so we can follow along. You see up at the top, I've got stack and list headers in lines 3 and 4. And that's because a stack, like a queue, is a container adapter. And so it needs an underlying container. In this case, we're using a list for that underlying container. And so on line 9, we create a list and we initialize it using an initializer list, which is a C++11 feature. And on line 10, we construct our stack using the list. And so we give the stack 2 type parameters. The first one is int for the basic type, and the second one is list for the container type. And then we give it li, which is the list that we constructed in line 9, and it makes a copy of that list. It does not use the list directly through references. And so on line 12, we use the size method on both the list and the stack so that you can see that they both have 5 entries. And then we're going to pop all the elements from the stack, and you'll see that they come off in reverse order. So popping them is 2 operations if we want to get the value. The pop method itself does not return the value, so you need to get the value separately using top, T-O-P. And so on line 16, we get the value of the top element, and on line 17, we pop it off the stack. And afterwards, we take the size again of both the list and the stack. The list still has 5 entries because we haven't touched that, but the stack now has 0 entries because it has been emptied. And then we list the contents of the list after the stack's been emptied, and you can see that that still has all its entries and they're still in the correct order. You'll notice on line 24, looking at the contents of the list, I'm using the range-based for loop, which is a C++11 feature, and you can see how nice and convenient it is. I like it a lot. On line 30, you see we construct another stack, and this is using the default container, which is a deck container. Deck is pronounced deck. It's not pronounced like it's spelt, which is DQ, because it's not a verb about removing things from a queue. It's a type of queue. It's a double-ended queue. We'll learn about decks later in this chapter. And so we create this stack. You can see it's very simple, and the deck container is actually well suited for stacks, and so that's why it's its default. And then we push some strings onto the stack. Very simple. Push, 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 push. 1, 2, 3, 4, 5. And then when we pop them, using the same syntax we did earlier, you'll notice that they come out in reverse order down here, 5, 4, 3, 2, 1. And that's the purpose of a stack, and that's what distinguishes it from a queue. And now the size of our stack is 0, and that's pretty much what you need to know about stacks. So I'm going to bring this back to its normal dimensions here. So a stack, like a queue, is a container adapter, only in this case it creates a last-in, first-out stack instead of a first-in, first-out queue. Now let's delete our working file and run clean to get set up for the next lesson.